My name's Doug Thompson, and we're going to make this video today to show you the basics of grinding. We're going to show the hows and, more importantly, the whys of grinding. Let me tell you about my background if you don't know me. I worked at Ford Motor Company for 36.5 years. I was a machine repairman by trade. I was in management most of the time, and I took care of the maintenance of 1/6 of the plant. That was 330,000 square feet of machines. Most of the time I was a flatwood worker, and I used the lathe whenever I absolutely had to. I started wood turning by chance. I went to woodhat.com and saw Johannes Michelson turn a hat. You know, I couldn't believe that you could make one. And what I did was call him up, took his class, and fell in love with wood turning. Okay, wood turning was my life. I'd go to work, I'd turn wood, I'd go to sleep, and I'd wake up and do the same thing again. About 8 years ago, I was tired of the high cost of tools and decided to make my own tools. Why not? I had a background in manufacturing. So in my garage, I started making my own tools. They worked out fine. Made out of good steel, good heat treatment. I was set for life. I had tools for the rest of my life. The only problem was I gave them away. Told my friends, look what I made. So I gave them all away, and all of a sudden I had to make more tools. And my friends asked for different shapes, different flutes. And I said, why not? I could do it. So I started manufacturing different tools. I always used a bowl gouge, but all of a sudden I was making spindle gouges and detail gouges. And what started in my garage 8 years ago for fun ended up being a business. It hit the internet. The internet, with all the forums, people all over the world reading them, we started selling tools. I didn't know if I wanted to make a business back then, but I said, yeah, why not? I'm ready to retire. It'd be fun. What I didn't know is how large it would get. And the reason for doing this video is so you can learn how to sharpen. I sharpen every single tool that comes out of the Thompson lathe tools. I think it's real important, and a sharp tool is a good tool to use. Okay, now we're going to talk about grinders. We use a standard 8-inch grinder that fits most of our jigs and everything like that. I use a high-speed grinder, but I suggest using a slow-speed grinder. It works just as well. You'll remove less steel, and it takes you longer to get in trouble, let's face it. The wheels I like to use are a Norton 3X K grade. It's a 46 grit for roughing and an 80 grit for finishing. So when you're touching up your tools, you're going to be using the 80 grit all the time. When you're changing a grind, you use the 46 grit. Okay, on wheels, we have to dress the wheels. Let's face it, the wheels clog up with steel. All the black marks you see in a wheel, that's steel embedded in the grain. Okay? Basically, the way we do it, the most common way, is a cluster diamond. Cluster diamond is just a bunch of little small diamonds held in a little holder here. We turn the grinder on and we run it across the wheel. The whole idea is to expose new grain. All that steel that's embedded in the wheel, don't worry about it. Just expose new grain. To dress a wheel and make it look pretty again doesn't do you any good. It wastes money that you spent. Okay? Let me show you the two different ways. We have a cluster diamond. You come across and just touch it. And that's enough to expose the grain. Okay, the other way is the Geiger single point diamond dresser. I really like this. Comes with a single point diamond, comes with a shoulder that rests against your platform, and an adjustment knob to run this diamond in and out. The way it's done: put your platform up here, lock her down, and you come up to the wheel, and you're going to take this adjusting knob, you put the shoulder against the platform, and you run that diamond in till it just touches. Okay? What happens here is you have a consistent distance between your platform and the end of the diamond. The reason why you want to use a single point diamond dresser is you can make that wheel concentric to the spindle shaft. So you have the spindle shaft here. Here's the outside of the wheel. And that dimension between the spindle shaft and the outside will be the same between all these points. Okay? If the wheel is concentric, you will not have a grinder that vibrates. There's no reason for it to vibrate. You could balance the wheels, everything else. That's all you need is that single point diamond dresser, and your grinder will run great. Okay, grades of wheel. Let's talk about that. If you start out at the letter A and go to the letter Z, letter A is soft. Letter Z is very hard. Our range is between an I and a K. I's are soft. Okay, what happens is when you start grinding the tools, the wheel's going to groove. You know, it's going to fall apart easier, you know, where a hard wheel resists that grooving. Okay, and it lasts a long time. And that's what I suggest. That's what I enjoy using. Well, we sharpen. The most misunderstood tool to get ground right is the bowl gouge. Okay, I'm going to show you a very easy way and the principles behind grinding a bowl gouge. If you look at it, we have a nose angle, we have the convex curve, we have the wing, and we have the bottom of the flute. Okay, we're going to start out with the nose angle. The nose angle is 60 degrees. Why is it 60 degrees? You know, 60 degrees is not very sharp. We sharpen an axe to 30 degrees. But 60 degrees allows us to start at the rim of the bowl and follow through in one cut to the bottom of the bowl. It's all clearance. It's not sharp, but for wood turning, it works out just fine. Okay, there's two different ways of sharpening. You could do it freehand, or you could use a jig. The system I like is the one-way Wolverine and the barrel grind. This includes the two base units, a V-arm, and a platform too. The other thing you need with it is the barrel grind. The barrel grind, if you open it up, gives you some instructions, not very much. You end up with this jig. It's got a leg on it. Now what do? I'm going to show you an easy way of setting this up. So it's very repeatable. And it's a very simple system to use. It's very versatile. Okay? So what I found out is you have to set the leg angle. The leg angle is the most important thing. Okay, and that sets the wing angle of a bowl gouge. If the wings are too far in, it doesn't cut well. If the wings are too far out, they don't hold up well. I have a setting here that works out perfect. Okay, it's very easy to use. What you do is take your Varigrind, put it right on the picture, and set the leg angle. Now let me move down here. Set the leg angle. You lock it down and never ever move it again. This sets the wing angle of a bowl gouge, and spindle gouges don't have wings, so why move it? Doesn't matter where the leg's at. Okay? Once we lock it down, to make it repeatable, we put the tool in. Now we have to set how much the tool extends out from the jig. The whole idea with this is to make it consistent. So we have the consistent leg angle and how much it extends out. One way says 1 3/4, and that's what I use. 1 3/4 from the end of the jig to the end of the tool. I have a block here set at 1 3/4. I tighten it down, and there, we're all set to grind. On the grinder, you have this V-arm that slides in and out, and this sets your nose angle. Now 60 degrees would be lower on the wheel, your 40 degrees would be higher. Okay, so we're looking for 60 degrees. And that's going to be somewhere around there. I'm going to lock it down, turn the grinder on. Make a little flat, and we're going to check it. Okay, I use a combination square. Okay, the angle that we're actually checking is down the flute and across the nose. So if you look at the board here, it's down the flute, and across the nose. And this is going to be 60 degrees. Okay? Okay, I can't see it there because I don't know if everything's right, but I could come up here and I could put that nose angle against the straight edge, and you could see that we're pretty doggone close. I think I do this all the time. Okay, so we have the nose angle. We're going to grind that to the very bottom of the flute. The next thing I'm going to show you is the secret to grinding bowl gouges. Okay, any bowl gouge. It doesn't matter if it's V-shaped or U-shaped, parabolic. This will show you how to grind the tool. If I make a convex curve from the bottom of the flute to the top of the flute, I'll show you how this works. I created a convex curve from the top of the flute to the bottom of the flute. This is going to give me an intersection from what I ground to the flute. If I grind the wings up to that intersection, this bowl gouge will be ground properly. Okay? Do notice on this too, this is a V-shaped bowl gouge. And notice that intersection is parabolic. Okay? That's what you want. You want a very slight curve in your cutting edge. Some manufacturers grind a parabolic flute, which will give you more of a curve. Okay? Most of the professionals like this. They want a very, very slight parabolic grind. Okay? I'm going to grind the wing. There, I ground one of the wings. You can see how it's following that shape. So that convex curve across the top of the tool will show you exactly how to grind it. Okay, if you look at other tools, we have our V-shaped bowl gouge, we have a U-shaped bowl gouge, we actually have a spindle gouge, all with that convex curve. Okay, so the pattern that that curve creates is how you have to grind the tool. The tool will be properly ground. You can see the V shape, it's got that slight parabolic. You can see the U shape is got a very large radius at the nose. And you can see the spindle gouge is also a large radius. Okay? That's the secret with grinding bowl gouges, spindle gouges. It all works off that convex curve. Okay, and now we're going to finish up the grind. So we have the rough grind on there now. Okay? So the next time you use the bowl gouge, it starts to get dull. All you have to do is barely touch it once across the grinder. And you're set to continue on. One thing I have to say is, how much pressure do you use? When you're touching up the edge and all you're doing is just taking a little bit of steel off, one finger of pressure. That's it, one finger. That's all you need. And that's how to grind the bowl gouge. Okay, right now we're going to describe the differences between a spindle gouge and a detail gouge. The physical difference is you take a piece of steel and you cut a radius in it. And say you cut a radius that's pretty deep, say 50%. What's going to happen? On the edges, it's going to be as wide as the piece of steel. That's a spindle gouge. Okay, a detail gouge has got a shallower radius cut into it. Okay? So therefore the flute is narrower. And you also see on the sides there's an awful lot of steel here. It's got to be removed. On a detail gouge, you'll see that's why we put that fingernail on it, is to remove all that extra steel on the side so we could create a radius across the nose. Now to grind them, I start out with the bear grind. Extend it out 1 3/4, come up to the grinder, and you can see that the spindle gouge is just a radius, okay, a very large radius. Remember what we did with that convex curve, okay? That convex curve across the top created a very large radius, and that's the intersection that we're going to grind to. Very simple. Turn the grinder on, come across here, and it's one sweeping motion. We have the spindle gouge. to grind the detail gouge. Because we have all that extra steel on the side we have to remove, we have to create that fingernail. Okay, generally a detail gouge is ground to more of a point. This tool is made for coves and beads. To grind it, the fingernail will sweep back farther, come back up. And that's how the detail gouge is ground. Okay, now we're going to talk about scrapers. Okay, scrapers are good. They get you out of trouble. They're easy to use. But let's talk about the basic scraper and what it is. Okay, you have a scraper. This is a side view. Okay, you have your nose angle. It's generally about 20 degrees. Doesn't really matter. Get in that range. The sharper you make that nose angle, the grabbier it's going to get. So about 20 degrees is fine. What happens on a scraper is when that grinding wheel is coming across that piece of steel, all this is ground away. But this very top edge, there's nothing to support it. So what happens is you create a burr. Okay, there's a little burr, a little piece of steel that rolls up. And that's the cutting edge on a scraper. Okay, what I do on my scrapers, I'll take a piece of steel. This is looking at the top. I'll divide it in half. The right-hand side, I'll keep basically straight across and knock off this corner so it doesn't catch. On the left-hand side, I'll draw it down here to a little curve. So your left-hand side, you could do the inside of a bowl. The right-hand side, you could do that little nub inside of a bowl or the outside. It gives you a lot of versatility to the tool. Okay? Let me show you how it's done. Now I have a very coarse wheel. I'm going to grind the left-hand side to a radius and the right-hand side straight. On this, I'm going to push very hard, then pull back, push. Okay, we come across. We have the left-hand side ground with a radius, and the right-hand side is pretty much straight. To grind this tool, you're going to start on the left-hand side here and come all the way around. By doing that, you're going to take this entire grind and move it straight down the tool. So if you're using the left-hand side only, you are not going to grind that area. You have to grind the whole surface. Okay, what we created here is a burr on that very top edge. Okay? Now that burr on this steel is good steel. It's only going to last about 45 seconds in each area that you use it. And after that, you would go back and grind it again. Okay? When you're talking about scrapers, if you're parallel to the floor, that's called a neutral rake. If you raise your handle up, it's a negative rake. So when you're on the inside of a bowl or something like that, raise your handle up a little bit. Okay? It gives you a little better cut, and you'll find what works for you. Okay, there's certain situations that you need a negative rake. Rather than raising your handle up, you grind that into the tool. Here's the way it works. You're taking that top surface and knocking the corner off. Okay, and that is your negative break. So your burr will be down here now, and that's going to push up, and when you grind this bottom section here, you'll have a nice little burr that's going to curl back. Okay? If you're inside of a box or something like that, that's when you really need it. Okay, here's what we do now. I have my platform, and by the way, the platform I like is the Robo Rest. Okay? That's made by Reed Gray, and it's wonderful. It holds the angle, it's easy to use, and I enjoy it. Turn the grinder on. And notice I'm putting a lot of pressure on it and backing off. And that creates your negative break. Now I'm going to show you a couple of tips and tricks sharpening a gouge. On this, it's a bowl gouge. If you look right here, there's a dip right before the nose. Okay? That's called a bird's beak. And what causes that is when you're rolling the tool between that radius at the nose and the wing, you're going to hesitate and you're going to grind too much off that area. Okay? That bowl gouge will not cut well. Okay, so we have to get rid of it. And to get rid of it is real simple. What I'm going to do is create a flat across the nose and then go through the standard grind. I created my flat, and now I'm going to grind the tool like normal. And the bird's beak is gone. The other thing, if you ever have a high spot, look at this side. This has got a high spot right here. I don't have to sweep across the entire grind to get rid of that. I could just touch the tool in that one area, take a little bit of steel off, and get rid of it. The whole idea with grinding a tool is to take as little steel off as possible. If you're ever at your friend's house and your bowl gouge needs to be sharpened and he's got his Varigrind and he says, "Don't move my leg, but you have to sharpen your tool," what do? There's a little trick, and basically we're taking everything we learned before and reversing it. Okay? So let's say his leg's out here. Okay. No problem. See, we had that 1 3/4 before with us. Well, it doesn't matter where it's at. Okay? We're going to set it there. Now you walk up to his grinder, and rather than setting the nose angle, we're going to set this V-arm so the wing is flush with the wheel. Okay, we'll take a little magic marker. We're going to mark that bevel. I'm going to put it up here, and we're going to slowly turn this wheel by hand. Can you see that right there? Okay, you can see how that wheel is touching equally. That line coming through there that we just ground off is very straight. That's what we're looking for. Okay? So we know that we're pretty much on the wheel perfect. Now we're going to come up here. And you can see we ground off all that magic marker. We have a sharp tool. It's really that simple. So basically we're laying the wing against the wheel rather than the nose against the wheel. And that's the reverse grind. Now we're going to talk about steels and heat treatment. We have different types of steels on the market. Some are from way back when, and some are newer steels. And let's go through them. You have the common steel now. It's an M2. It's got another one. It's M4. And let's see. You have a 2030. You have a 2060, and you got a CPM 10V and a CPM 15V. The difference between all these steels is how much vanadium they have in. So you take the M2, that has 2% vanadium. The M4 has got 4% vanadium. 2030 has got 5% vanadium. 2060 has got 7% vanadium. CPM 10V has got 10% vanadium. And the 15V is 15% vanadium. Okay, so you can see the difference in them. The better the steel, the more vanadium it has in it. Except when you start coming up to the 15V. I make one tool out of that. And it's a roughing tool. It's a bowl gouge. Basically, if you want to rough bowl after bowl after bowl. It's got 15% vanadium in it. It holds an edge good enough. But there's a point where you get too much vanadium in it, where the really sharp edge starts to break down. The steel gets brittle. Okay? So this one, basically, we're not going to talk about. The 10V, it's a 10%. All the rest of my tools are made out of this 10% vanadium steel. And it's just absolutely wonderful. It holds an edge longer than anybody else's because of that wear resistance. And let's face it, vanadium's in there just for wear resistance. Okay, this steel is actually used in the industrial world for centerless grinders, dies, stuff where it takes a lot of abuse and it holds up well. Okay, let's talk about these steels. Most of these steels, you'll see these are all imports, you know. And this one here, the 10V, is made in the USA. Okay? So it's real simple. The more vanadium they have, the longer the edge is going to hold. These tools are made out of powdered metal. Okay? Let me explain the way standard steel is made. They take all the elements and put it into a pot. And they melt it and they pour it. Okay, when you start getting the high percentages of an element, the steel needs to be in a powdered form. So those elements are dispersed evenly throughout the steel. So basically each element is run up a chute in a molten form. With compressed air, it's blown. It turns into little droplets. And these little droplets are sifted out and sorted, and when you have enough of each component, each element, they're put into a mixer, just like a mixer at home. And then all that material, after it's mixed up, is poured into a form. That form is heated just enough where each element bonds together. Okay, after that, you'll take that block of steel and start running it through rollers. And that's how you get that powdered metal to a round state like this. Our tools are hardened, tempered once with heat, cryogenically treated. That's where the steel is brought down to a minus 300 degrees, and then tempered 2 more times with heat. They spend about 50 hours in an oven and about a half a day being frozen with the cryogenics. I get a lot of questions about cryogenics, exactly what it does for the steel. Cryogenics doesn't change the steel, it just makes it better. When you harden steel, the steel becomes very, very brittle, okay? And you have to change it from a brittle state to a usable state, okay? And that's done by tempering. When you temper a piece of steel with heat, it changes the structure. These again are tempered 3 times with heat. But that second temper is done with cryogenics, which is part of the tempering process with this steel. Cryogenics is basically working on freezing. It's a deep freeze, where they start out at room temperature and the steel is dropped down to a minus 300 degrees. During this time, there's changes inside of the steel. The structure is changing, okay? And it could only be done with the cryogenics.